right, next on the agenda, section 5.7, which is about inverse trig functions. So an inverse function is essentially a reverse function, so sort of running our functions in reverse. Right, sounds kind of like reverse. And so in this case, we're trying to sort of reverse our trig functions. We're just really going to look at sine, cosine, and tangent as our sort of big three. So we're going to look at the inverse functions for those three. Generally, right, a function is sort of taking x values and sort of mapping them to y values. The inverse function is sort of reversing whatever that connection is, sort of taking your y values back to the x values. So if we take something like the sine function, right, what you're doing is you're mapping an angle to a value between, right, -1 and 1. If we think of like what were our outputs for the sine function, in theory, right, it's that sort of opposite over hypotenuse. Once we've expanded out, done all of our unit circle stuff, the range for the sine function was -1 to 1. So sine inverse is going to sort of reverse that, right? So that means sine inverse is going to take a value somewhere from -1 to 1 and map it back to an angle. And for us, this is going to be an angle particularly in radians. This is going to be true for cosine inverse and tangent inverse. They're going to reverse back to an angle, and the angle is always going to be a radian measure, right? Radians are our angle values that sort of work best with our other numbers. So as we try to define this as a function, what we need to do is use those radian values because they're the ones that sync up better than our degrees. We did some calculated versions of this back in like 5.2 for some of those right triangle problems, right? There sort of is a calculator button that can do this. But so now what we're going to try to do is really sort of get this mostly from a unit circle context. So what we're going to do is let's define, so y equals, what's this going to look like? So sine inverse of x, we're going to use the sort of inverse notation, which is the sort of -1 exponent. It's super important to note, and this is a little bit of a confusing thing, so this is not the same as like 1 over the sine of x, right, which would be the cosecant of x. So this is not a reciprocal. This is an inverse. This is an extremely confusing notation. What you see is sometimes you'll see sine inverse of x written as arc sine of x. But in this section, we're just using this sort of inverse notation. The arc sine is to try to avoid this confusion between what's an inverse and what's a reciprocal, which for these trig values is legitimately a problem. So if y is going to be the sine inverse of x, this means that the sine of whatever our y value is would take us back to x. Now there's a little bit of an issue, and so that is, let's sort of like look at an example, right? So let's say I wanted to do sine inverse of 1/2. And so you say, okay, so this is supposed to be the angle where sine of that angle equals +1/2. That's what we're really asking. And so this could happen at pi over 6, or it could happen at 5 pi over 6, right? So for a sine function, there are sort of two different possibilities here. There's sort of a quadrant 1 possibility or a quadrant 2 possibility. And so one of our sort of first hurdles is like, to be a function, we can't have two outputs. And me saying two outputs here, I mean, that's really just the tip of the iceberg, right? Because I'm not talking at all about any kind of coterminal type answers, right? Or negative rotation type answers. you could in theory have, an infinite number of angles, right? Every time you rotate around to one of those two positions, you're going to hit that value 1/2 in the sine function. So in theory, okay, the inverse value could be one of an infinite number of angles. How the heck are we supposed to pick here? And so what we're going to do is we're going to pick essentially what is the nicest possible version of the answer, right? I mean, if you were sort of just doing this, you would probably just pick the quadrant 1 angle. So we're going to define this as pi over 6. So we're going to sort of restrict sine inverse of a positive value to a quadrant 1 angle. So this is just to sort of make this work as a function. Obviously, right, if you have this in a little bit more of a general setup, you're just trying to figure out what are the possible angles where such a thing could happen. There's a bigger span than just quadrant 1. But just to get us started and to make this act like a function, this is the kind of thing we need to do. What about sine inverse of negative 1/2? What about sine inverse of a negative value? We have a similar kind of issue, right? So this is going to be an angle where the sine of the angle equals negative 1/2. So in theory, right, if we just think of kind of once around the circle, that's going to happen for us at 7 pi over 6 or 11 pi over 6. So that's a quadrant 3 angle. This is a quadrant 4 angle. We have this same issue of two different values, and what the heck are we supposed to do, right? We really just need to pick one of them. And one thing here to consider is okay, so if I've in some sense let me sort of draw a little bit of a sketch, right? So if I've got quadrant 1 is here, right? So that's going to be sine inverse of some sort of positive value. My options for the negatives are quadrant 3 or quadrant 4. So that's sort of down here or down here. Quadrant 1 and quadrant 3 would make a not wonderful pair, right? I mean, those guys aren't really connected. Quadrant 4 is sort of next to quadrant 1, so that maybe makes a little bit more of a natural option. But if I think about what the measures would be, this would be sort of 0 to pi over 2. This would be 3 pi over 2 to 2 pi. It's still this sort of weird chunking up of the angles, right? A section here and then another section here. So what we're going to do is we're going to use quadrant 4, but we're going to use negative versions. So 11 pi over 6 would be here. Another way to get there into quadrant 4 would be to just do a rotation, but do a negative rotation. So sine inverse of a negative value. Sorry, this is just supposed to be any negative, not just negative 1. So any negative value, it's going to be quadrant 4, but it's going to be sort of rotated in a negative direction. So instead of 11 pi over 6, what I'm going to use is just the negative version of pi over 6. This is a couple things. It gets me two connected intervals, right? So then this is going to really span from, so we can kind of define maybe more particularly, right? So y equals sine inverse of x means the sine of y equals x. And this is going to be where our outputs, so y is somewhere between negative pi over 2 and positive pi over 2. So what we're doing is we're sort of restricting the range on the inverse function. Said another way, we're sort of restricting the domain on the original function. So this is sort of the inverse of a restricted version of the sine function. So this is sort of sine only running quadrant 4 to quadrant 1, sort of negative values to positive values. And so what happens when we do that is we get essentially just like negative and positive versions of the same angles for our answers, which is pretty nice, right? So sine inverse of 1/2 would be pi over 6. Sine inverse of negative 1/2 would be negative pi over 6. So we're going to use this like restricted range / restricted domain. We're going to use this sort of restricted unit circle to get these values. if we sort of take that information and then we do just like a couple short examples. So let's say, for instance, sine inverse of like root 2 over 2, right? So the whole idea here is this has got to be a positive quadrant 1 angle. So what is the angle in radians where the sine value is root 2 over 2? If we check our unit circle and just sort of scan it, maybe we've got it memorized. What we're going to see is the angle where that happens is positive pi over 4. And we don't need to worry about the other ones going around the circle. Obviously, this happens in more than one position. We're not trying to necessarily, right, hit all of those options. Sine inverse of root 3 over 2, right? So this is supposed to be a quadrant 4 angle, but it's a negative version. I mean, in some sense, we can really just look at quadrant 1 as sort of a reference position and then just have a negative version of that angle. This is going to happen for us right at pi over 3 if it was a positive. So the negative version is going to happen at negative pi over 3. So you can kind of almost get all of your answers from that first quadrant, and it's just the positives give you positive answers, the negatives give you negative answers. It's sort of the nicest possible connection. We've got a couple sort of more extreme ones if we think of something like our positive negative 1 type answers. Sine inverse negative 1. That'll happen. That's sort of right down here at the extreme, right? That sort of happens at, what would be kind of our 270 degrees position. But again, from this perspective, that's going to be for us the negative version of pi over 2. So we're going to define our sine inverse to run over that particular interval. We're going to have similar restrictions for cosine and tangent inverse. We'll run those down in the next video.